flowers to those in the dev community. And if you're not a part of it, worry not, relax. We got you. That's why we're here, so that you can be a part of this. We have various different facets in our developer community, the open community, the women in tech community, and all other aspects. And this particular one is the AI and machine learning community, artificial intelligence and machine learning community. So our AI ML community is the newest baby in this community field, but started this year and is growing very, very well. We have monthly meetups, and this is the one for July. That's why we are here today. The topic will be securing the digital frontier. So techniques and tools for data privacy in the age of big data. So without further ado, I will not take more of your time. I will allow you to get a deep dive or delve into the content as is. Feel free to engage with our speaker, who will introduce himself, Ben Maine, through the session, and you can always comment in the chat if you have any questions or any additions that you'd like to be addressed. Yes, those are our speakers. As you can see, my name is Sylvia Chabet. I work at Africa's Talking in developer relations and lead the Women in Tech initiative. That being said, welcome all those people across, whether you are in Kenya, Uganda, Tanzania, wherever you are joining us from. Hopefully you will get to achieve the aim you had when you joined this. Gain more content, gain more knowledge on something new, and that is the goal. That being said, thank you very much. Over to you, Maine, and yeah, have a good session.
Yeah, thanks so much, Sylvia, for the intro. And first of all, can you hear me okay? Yeah.
Yes.
Okay, great. Yeah, I've been having issues since I swapped laptops. Anyway, yeah, so my name is Maine Ben. I work as a data scientist at Africa's Talking, and I do a lot of machine learning. So let's just dive into what you're going to talk about today. And just bear with me. This thing is okay. Good. Yeah, that's me again. Yeah. So welcome again to the AI ML community. And today I'm going to be talking about securing the digital frontier, techniques and tools for data privacy in the age of big data. So you can say, in other words, we're just pretty much going to look at data privacy and anonymization, in case that's a mouthful. So usually before the presentation nowadays, I give out the materials, normally because something happens in between, and some people might not get the material, or yeah, just some complication here and there. So if you can, maybe take a screenshot of this, and then you'll have access to the slides, and you can use the tools here. Yeah, just let me know if you've gotten the material. Okay, one thumbs up. Maybe if I get like another maybe 10, that would be nice. Oh, yes, it's also okay. Okay, we have 3, 4, 5. Okay. Okay, that also works. This is for the next, what MK has just posted is where you can find the repo that has basically the bulk of what I'm going to talk about today. Okay. We are cooking. Okay. And there was that as well, which is the repo that has just been posted over here, and it has been pinned. Thanks so much, MK. Yeah, so you can use these materials to either follow along, but yeah, I'd really pay attention to whatever it is I'm gonna say today, because it's super important to be laser focused on the material. So what we'll cover today, this just will be a couple of things, and just so that you know, this I've done this presentation before. I've like added a couple of things. So we are just going to cover a couple of definitions that are relevant to this whole presentation, and we'll primarily talk about techniques, which is surprisingly data deletion, masking and sampling. We look at privacy models, K-anonymity, principal component analysis, differential privacy, embeddings, T-stochastic neighboring embeddings, and federated learning. I know some of those terms sound really scary, but we are going to go through them, so not to worry. So when the word data privacy comes to your mind, I always remember this GIF where this high school girl is like preventing this guy from going through this certain hole, and that's akin to what happens in data privacy. The ones to the left are just formal definitions that you can use maybe when you're asked to talk about this particular topic, maybe in school uh, or somewhere else. But it's just simply the process of segregating data and controlling access. As in, what that means is like when you're handling, like let's say you have this whole data science team, or in a company, you can't really give access to specific kinds of data, and we'll have our, and as we go through the presentation, I'm going to go through specific things that can help you like through this whole process of segmenting data in terms of who has access to what, and it's a really important thing. And honestly, at least from the time I started this career, like this is one of the most important like aspects of data science, and it can actually propel your most data science projects. So yeah, data privacy. So before we move into the particular terms, uh, where in the world is Carmen San Diego? So if you guys have heard of or you've watched like Carmen San Diego before, like nobody really knew the who or what was Carmen San Diego's real name. So there's this old series that I think used to be aired on KBC. I could be wrong, because yeah, this is probably this information I got in the internet. So there's the old one where she looked like a man, where I have no idea. But the new one is pretty good. So if you're a fan of Carmen San Diego, you should check it out. So there's a term there, personally identifiable information, or PIIs, and I'll say PIIs because that's a very long word. So PIIs can come in three flavors. So there's a sensitive, non-sensitive, and quasi-identifying. So the sensitive ones are the ones that can be able, that is the kind of data that you can use to identify you. And could anyone in the audience tell us like which one matches that criteria among these three bullet points here? And maybe you can give an explanation if you don't mind. Anyone? Oh, and it was on KTN. Haha. Okay, so yeah, okay. Okay, biometrics. Someone has said biometrics like fingerprints. So that can identify you, but with biometrics like fingerprints, like what happens is you can burn them off. Although that's a very extreme thing to do, but that's one way. Yeah, thanks, Senna. So yeah, there's biodata, and things like name and phone. Okay, those are good attempts. Yeah, stuff that can identify you. Like here's one example that I've like highlighted here: genetic data. This information is something like if you have access to, maybe you've done a paternity test, or maybe you have just been interested in finding out uh, maybe your origins, as an example. So 23andMe used to do that. I'm not sure if you can do that here, but if you do it here, it's probably gonna be super expensive. So this information has like a blueprint of basically what makes you. And if you have this kind of information, like you can identify someone pretty easily. And that is on the realm of sensitive PIIs. And the non-sensitive ones, that they are not quite, you can't really use them on their own to identify someone. So you'll need to you need to probably enrich it with more information. So things like country of origin are something that that's usually non-sensitive. And then once you combine information together, there's a way you can actually identify people. And there's this computer scientist called Latanya Sweeney who was able to identify that in like US. So if you're able to combine the name and what was it? The name, birth, postal code, and let me see. Yeah, name, postal code, and there was another one. Not remembering, but if you're able to combine this information together, you can actually be able to identify that someone in US. I don't know if that situation has changed. And then there's something interesting about the professor's name, Latanya Sweeney, and yeah, so like she also noticed that when she searches for her name, at least at that time, she noticed that her name is mostly associated with criminal activity or criminals, and that's not a good thing to have. And if you're a professor, it might ruin your rep. But if you're if you do gangster rap, that could be another. That would actually increase your rep or something like that. Yeah, so that falls into the realm of quasi-identifying information. And once you have all this information like put together, you'll be able to achieve now something called anonymization, and you'll be the real day Carmen Sandiego. All right. Now there's another sensitive topic, which is data deletion. And usually just to follow particular data privacy laws, it cuts across GDPR and the Data Protection Act you have to think about things to do with data deletion, and that can be a very sensitive area. So how do you actually plan for it? So the first thing you do is to come up with something called a data inventory. And what that is like, you can think of it as a catalog of all the data that you've stored, maybe about your clients, maybe about pretty much anything you have as a business. Like you put it together, and then once you put everything together and you have this whole catalog and you have all these business functions, you also, when you have that in place, you can be able to control access because you have all this and specific business functions. You're supposed to, this particular person is supposed to be able to do this, this other is supposed to do this. So it becomes easier to separate out if this person's function is this, they're supposed to have access to this particular thing. Okay, and then comes the segregation strategy. So there are two things to put into consideration, and these are just, what do you call them? Recommendations from that book that I've recommended down there. And for operational data, it could be stuff related to the business, like how many maybe sales did you make this particular month, things like that, things like profits, things like particular statements. Like these guys from that book recommended like wherever you're storing it, you can keep it for 10 months, but obviously this is just a recommendation. It can be different for the different things you're probably doing. And then there's archival data. This is mostly stuff that maybe people like data scientists or machine learning engineers could use to do things like maybe customer segmentation, maybe predicting churn. So customer segmentation is something to do with like maybe grouping clients who have similar properties into particular, what do you call them? You can say groups, and then you're able to maybe sell a certain product to those particular groups depending on their properties. And then there's for the churn is just the likelihood that this particular client will stop using a service if your business is a service-based business, and there's a way you can calculate the likelihood of that happening per customer. So data like that. So data like that, you need like a substantial amount of data, like something maybe over 30 observations to be able to figure out these things properly. And then there are two like services you need to put into consideration. This is a retriever and a destroyer. So at some points in time, if you're collecting client data, they're gonna, some specific clients can ask you for their data, and it's their right to actually you to provide that particular data. And like if you have that particular service or image that can help you do that, it makes again these processes of like compliance really good, and yeah, you get into trouble. And then the destroyer, like sometimes like a client doesn't want to use a service anymore, and then they'll require you to maybe delete all the data you have about them, maybe from databases, object storage. So if you can compress that into a single like service, that would be the best. And I don't know if you guys have ever asked for your data, for instance, for particular services like Spotify or Netflix. Because the last time I asked for my Netflix data, it was in a really unusable format. So if you're practicing this, it would be nice to have it in a format at least your client can be able to use, because that was shame on Netflix. Or you can get into a lot of trouble if from clients if you don't. And usually this can be for overseeing all these processes. It's good to have this privacy engineering team. Remember, this is just a term from the book that you need to, obviously you can call this something else. This is just a recommendation. All right. So why should you care about this data privacy stuff? And here is like a summary of some cases that have actually happened here in Kenya. So ODPC is the Office of the Data Protection Commissioner, and you need there's it's a particular laws that you're supposed to follow, which are in the Data Protection Act, which I encourage you guys to read. And then there's another thing is like when you're like maybe for instance taking photos as an example, you need to ask for consent. So those who have the habit of just randomly taking photos and putting them on social media without the person who's in the image, without asking them for their consent, you can get into a lot of trouble. And as an example over there, you're seeing some companies that have been fined. Like on the right, you see the Roma school was fined like 4.5 M for using photos without parents' consent. That's something like if you have the links down there, you can maybe read more about. And a brand like for phones, Oppo Kenya was also fined for using photos that they're not supposed to. And there's another one where 3 companies were fined like a ton of money for not following these data protection laws. Yeah, so it's scary, but again, if you have this information with you, you'll be good, so not to worry. So after all that explanation, it's time to enter the matrix. And I warned you guys, I'm gonna say a lot. I'm gonna use a lot of the matrix spans and images just to illustrate that most of the work we do is in a matrix. All right. So I have an exercise for you guys. You have a data set over here at the bottom here, and we have a summary of the data set over here to the left. Can someone tell me what this data set is about just by having these two pieces of information? So here I used, okay, before I say more stuff, could you tell me what this data set is about? Again, you can unmute and say something, or you can leave your ideas in the chat.
So hi, can you hear me?
Yeah, I can hear you loud and clear.
So from my observation, I would say it's insurance data from an insurance entity.
Okay.
Yeah.
Another person wants to try? Okay, there's hospital or clinic. Patient data for chronic and congenital illness. Okay, nice. Last time I asked about this, like I mostly got wrong answers, but hey, you guys are in this are within the ballpark of what this is about. And yeah, just for the sake of revealing what's going on here. So there's this tool called pandas, and we use that for data manipulation. And here, this is just a concise summary of what's going on. The column names here are, instead of being actual names, they're numbers between 0 to 12. Then we have like 1001 entries. These are the data types over here. This is how much memory it's using. So yeah, this method for pandas is what I use to create this. And then we have the data frame head, and this is what we get, a couple of observations. Yeah, and actually, if I removed some columns over here, it would be pretty hard to figure out what this is about. So that's the first technique. It's called masking, where you remove the column header. Yes, the column header, and then you put numbers from that take the length of the number of columns in the data set. That's another way of masking. And indeed, this is a insurance data set, like the first person commented. The rest, yeah, we're in the same ballpark, but yeah, this is actual insurance data. And if you are looking at the repository right now, there's a folder called codebook, and there's a txt file that you can look into to know what these particular columns mean. And if you've been to the previous meetups, like I always encourage you guys, when you're sharing data sets, to always make that codebook. And if you've done competitions as well, you're normally provided this for the most part. And also in your day-to-day work, always provide codebooks as you're sharing data with people. Yeah. So that's masking. So another technique is sampling. So whenever you're cooking, you don't normally eat the whole pot, as in whatever it is you're like trying to cook it. Maybe it's beef stew. You don't like eat the whole thing to figure out that this food is salty enough. You usually take like a subset of, or a small chunk of that food, and then you can taste, and then you can figure out, oh, this is salty enough. So this is the same kind of thinking with sampling, where you just take a subset of the data, and then you calculate a metric like mean or a sum or some or things like those. And one, oh, Wow, this one went straight into the code. Okay. So the first sampling technique is what here I'm just showing you the code. If you have some time, we can go to the code step by step. That's why there's a second tab there that looks into the app. It has the symbol of the Jupyter thing. So we're going to look at that later. I'm just showing you some highlights. So here we're just taking a sample of that 1,000-row data set, and we are trying to calculate, we are trying to look at the marital status of these particular people who use this insurance service. And then you get a couple of numbers which represent the proportion of people who are either separated, single, married, widowed. Then there's one for registered partnership. I think that's same-sex relationships. I don't know if that is that is done here, at least from my limited knowledge. I'm not sure about that. And then there was another property, which I'm kind of forgetting right now. So what happens here is we are taking a bit of that data, and then we are using P means the likelihood, so the probability. So here, if you take the values, it will give you a certain range of values, and we are doing this for that particular sample. Then you'll notice, like, if you calculate this particular, so these are like the proportions of how many people within this insurance service are separated, single, married, and widowed. So 38% are separated, 22% are single, 21% married, and 19 widowed. And then you notice, like, there were some groups which I missed, but if you calculate it like normally, you'll get numbers close to this. And so that also brings me to the point of this whole thing. So like the reason why we're using these techniques is mostly to protect like very small groups. And sometimes these small groups, people can single them out, like as when you're presenting this to a large group of people. Like let's say you're the Bureau of Statistics, like the one we have here. Like there are particular techniques like this you can use to like present information as an example, just to protect particular groups. Where if there's a need to, but most of the time, like you don't have to give out all all the information, especially when you have these external presentations as an example, like maybe this one. You can just give something that's around the ballpark, and this sampling technique can help you now. What do you call it? It can help you give like a smidgen of the data set that you can use to present to other stakeholders. So that's sampling. And then here we have an image of 3 Spider-Men. If you watch Spider-Man. Yeah, I'm not so good at Spider-Man movies. So one is maybe Tobey Maguire, and another one is maybe, yes, guys, help me out. Like if you've watched Spider-Man, one is Tobey Maguire, one is like the I've forgotten the Spider-Man names. Yeah, so Spider-Man has been acted by a couple of people. So this whole, oh yeah, okay, we know it's Peter Parker, but there have been different Spider-Man movies, and these different Spider-Man movies, they've had like different costumes. So the actual names of the actors, yeah, Tom Holland, good, forgot that guy. And there's another one with long cool hair. I forget his name. Can anyone tell me? Oh yes, Andrew Garfield. Nice, you guys watch Spider-Man. It's such a good movie. So this is another technique called K-anonymity. And here again, you're trying to blur out the particular groups. And here, I'll let you know what was happening over here when you get to the code. But the technique I use to move the ranges of edges from this to something small like this, it's a very common function that I normally use, like for a lot of use cases, including even that calculating churn thing. So it will come in handy for even something called feature engineering, which is just making more data to enrich your models. Yeah, so can't wait to show you guys that. So here we are just looking at the age and tire. Tire was something to do with how much money these people actually put aside for this particular, for the insurance, the health insurance. And it's broken down into bronze, silver, and gold. And here, after now calculating summary statistics about the age, you get something like this. So as opposed to having this whole data set when you're sharing, you have this small one here. And as you can see, even here, the proportions are pretty much the same. And because here, maybe 30 to 41, it's like 26%, 53 to 63, 25, 41 to 52, 25, 63 to 74, a bit lower. So it's very hard to ascertain what particular group is. Okay, here you can say it's majority here, but then if you round off, like you can barely separate this from the other. And this is the whole essence of K-anonymity. It's a way of reducing distinctions between groups. And oh, here's the actual code I was using. And then there was, so what's going on is, this is the actual function I was talking about, like for reducing the age into like 4 bins, and then you get something like this. Then once you've got something like that, you now do this. This will just give you the number of instances of that particular value in terms of that probability kind of situation over here, or these proportions. And then once you do that, if you calculate the groupings again, this should not add up to 4. Yeah, a data set should not come out after doing this. So this is basically saying like you're not supposed to have mostly singled out groups for this particular data set. So you've literally just blurred the data like totally. And some of these techniques can come in handy. Maybe you have like data in maybe a data warehouse, or maybe some S3 bucket, and you want to be super duper careful just in case something happens. These are some techniques you can use, especially if the data is not, you don't really require the data to be super accurate. So another one is like differential privacy, and this one is practiced a lot by Apple. And has anyone heard about this technique in the audience? Yeah, so just repeating my question, has anyone heard about this technique, and how has it been applied, this particular technique, if you've ever heard of it? So you can use the chat, you can unmute and say something. Okay, I will take that as a no. So, Priscilla, go ahead. That's how you say your name? I hope I'm not butchering your name. Or was that a mistake?
Am I audible?
Yeah, you're audible, loud and clear.
Okay. Before we move to this one, I just had a bit question on K-anonymity. Is it like encrypting? Is it like encrypting the data so that it won't be seen? And then when you want to retrieve it, do you decrypt it using the same formula?
Okay, so you can think of it. Okay, it's okay. Like in my statistical modeling head, I'd say it could be a way of encrypting data, depending on, because you're moving from this big dimension to a very small dimension. You can think about it like that. But if it's maybe the typical computer sciencey definition, you couldn't like encrypt, not so much. But the whole point of K-anonymity is for you not to identify those particular groups. Let's say you're protecting a certain group of people, like who you might not want to be shown within the data set, as an example, like maybe those cases for registered partnerships. if it's maybe a crime to have that here, wherever you are. And yeah, it's more of a way of protecting the identity of particular groups of people. And yeah, like, how's that? Have I answered your question?
Yes, answered. I also take it in part of research where you don't want the people who gave the information to be identified.
Yeah,
Yeah, so
that's
I'm answered.
okay, great. Right on. Okay. Yeah. So when we move to differential privacy, we have these two things. So number one is when we're talking about differential privacy, you're talking about like when you have like data, how can you add noise to it to prevent, like, for instance, having very accurate like data. And that brings me to uh, this text over here called epsilon. So this epsilon the is you can just say the amount of leakage. Like it's like if you give like a lot of leakage, like epsilon is equals to 10, then you get very accurate values when you're calculating like particular metrics. But then if you give a small value like 2, you get a very big, you get like the most accurate, like what do you call it? You get the most accurate like data, like when you're calculating a metric. So here, an example would be maybe you have a data set of people with very rare like diseases, like maybe what rare disease can I think about right now? Diabetes insipidus is one. It's pretty rare. Like the one that people probably know about is diabetes mellitus. That is just having like high blood glucose, like the one for diabetes mellitus. And if I'm wrong, you can please correct me. And the other one could be one. And let's say you have data about the staple food of Kenya. That's another one. So if you have calculations like those, as an example, like you will, like there are some which is like basically common knowledge. So that one you give a value of maybe epsilon is equal to 2. And I'll give you a better example just to illustrate this differential privacy properly. So just hold on. So once you have a data set like that, and you want people to have access to it, like if it's stuff to do with common knowledge and you're sharing this information, maybe a small epsilon value would be good, and then a big epsilon value would be good. Sorry, and then like for the data set where you have like clients with or particular people with very sensitive information, you probably put up an epsilon value of 2. So let me give you an example of where this is used a lot. Like in Apple, when you're using your Apple keyboard as an example, or I don't know if Google implemented this, but so like let's say you want to know what are the most common emojis that people use as an example. So what happens is like Apple will use a certain function to help them do that. So that brings me to this slide where like here's an example of this differential privacy in action. So what happens is like Apple is going to put a differential privacy system where there's this thing called a budget accountant. So what that does is it will keep track of this epsilon parameter, and if this value like adds up, like reaches 0, that means this data will be super random, and you won't be able to even run, I mean, people won't even be able to query this particular data set because you have used up your epsilon value. So here, I'm just getting random values, like from 1 to 9, and they're integer 32 numbers, size of 10, so that means they're 10. So, okay, 10 numbers. So, wait, yes. Am I confusing myself again? Okay, let's just say 1 to 9. 0 is included. So 0, 1, 2, yes. Yeah, if 0 is included, since Python you count from 0. Yes, 0 to 9. Yeah. So someone says bilharzia is quite rare. Yeah, actually, that's actually true. Bilharzia is a very rare condition. It's just very interesting condition, because you need to be in a swamp, and then you have to be bitten by a certain what do you call it? Secaria. I think that's the parasite that if it bites you, you start developing bilharzia, which you might end up getting like very bloody urine or stool. That's like an example. But let's go back to differential privacy. So yeah, there's this budget accountant. So when I'm doing this calculation for calculating mean, this is a library by what do you call it? IBM that helps me do this differential privacy. It's called diffprivlib. And so when I'm calculating the mean of this particular array, which has values between, here I said 1 to 9, and then I think it's supposed to be 0 to 9, but anyway, what happens is like when you calculate this, and then when you calculate the original mean, you'll get that this mean is like maybe 4.8, and the other, like the original mean is 4.8, and this one is like 4.77. And yeah, that's the whole point of differential privacy. It's either going to remove a particular value within the array, and then that will like change the mean that you get, or it can change the accuracy of the numbers. Instead of having like super accurate numbers, maybe 4 decimal places, it can be something low. So the whole point of this is just adding noise to your calculation. That like the whole point of noise is like either removing values in the array, or maybe changing their accuracy. And then once you've done that, you can also calculate your budget so far. And then once that's done, you can be able to compare the calculation. So you can think of, now back to the Apple example. So for the Apple example, they have a system like this. Maybe people want to query, maybe it's like a certain university is doing a study and they want to know this kind of information. So they have this whole system set up where they have this budget accountant, and they've set an epsilon parameter. And the more you query, the more data that you're given. That's like a rough estimate of the most common emojis. But again, this technique is not like foolproof. Like if you do enough queries to the original data set, you can find that you can get something close to the original data set. That's why we have this budget accountant. Like if you have a very small epsilon value, that means you have like smaller instances where you can be able to, what do you call it, make the whole data set again. And this function will fail. And once maybe engineers see that, they'll be able to say, okay, this has failed. That means these guys are querying this thing too much. And then you can find out what's going on within that particular study for finding out what's the most common emoji that is used. Okay, enough of differential private. Okay, someone said something, Ronnie. If one adds audios with noise in a speech recognition, does that quantify to be an example of differential privacy in practice? Epsilon could be equated to a parameter controlling the level of salt and pepper noise added to an image. Okay. Yes, for first part for speech recognition, you can think of it as that, but there's also there's another parameter. What do you call it? Yes, let me not overcomplicate this. So yes, that you could say that, but you have to have this level. Okay, if people are querying that particular source of data, and maybe you have a way to like change it, like I guess dynamically depending on level of access. Like again, this is another technique of maybe you do not like, depending on someone's level of access. Like, do you remember that thing I talked about, segregation? You might give very accurate values to particular groups of people and not so accurate values to another group of people, especially external ones. And yeah, this kind of information. Yes. So what Ronnie says there, yes, you could think about it like that. And yeah, thanks for that addition. So let's move to something interesting called principal component analysis. And this is basically the summary of what goes on with principal component analysis. And for the people who've been doing a lot of competitions, maybe in Kaggle or Zindi or drivendata.org, like you've probably come across this technique because a lot of data science competitions, you're given like a lot of data. And what this helps you do is basically see data in a different perspective. So in terms of, instead of having these many columns, this technique is going to compress all that information by rotating the data within, like in a certain way. As you can see here, the data looks like this for the sepal length and petal length. This is from the iris data set. And you see it moves from this to this. So you can think of it as the data has been rotated. And once you have data that looks like this, it's easier for you to, when you're making a machine learning model, like the model is able to maybe make the decision boundaries like better. And just to take a step back, when you're in machine learning, like these algorithms that you use from SVM, spot vector machines, random decision tree, and things like logistic regression, there's a certain way they make decision boundaries. And what that means is, like, you see how the data has been separated into 3 groups based on color of this particular class. Now, what the algorithm will do is like put a line in a particular manner. So maybe it will put a line here. This one will be a bit tricky. So probably put a line there. And then, sorry, and then put it around here. Something like that. You see, it's easier to make a line from this data, which is these particular observations, to something like this. See, it's easier to make that line. Maybe there will be one that's classified a bit badly, but it's better than something like this. So that's the whole point of principal component analysis. How can I view my data in a different angle? And I've seen someone with that interesting, I need to add it to one of my slides, that I think it's Karani, the one for, yeah, there's someone in the audience called Karani, like here's that image of that particular image of that guy looking at this lady. Yeah, maybe you wanted to look at her in a maybe different angle to see a better perspective. So that's another thing. So he was doing principal component analysis, like in real life. Yeah, so principal component analysis is just, it's also a data compression kind of thing that you can do. So if you have a lot of data, it's a way of maybe putting it into a smaller representation, and it will also retain the original characteristics of the data, as you can see in these 2 images. Like this data set and like this representation in a plot, and this representation is pretty much the same. And that's the cool thing about principal component analysis. very good technique. I recommend you guys to look into it, and maybe you'll win a lot of competitions and make a lot of money. Another technique which is almost in the same ballpark of what do you call it? The whole unsupervised learning kind of situation is embeddings and t-SNE. So what happens is you can have maybe categorical data like this one, and then instead of having it as text like this, like gender, occupation, education, you can have it in a bunch of vectors. So this is it. This is a way of representing the same data. Then if you take the same data and apply these t-stochastic neighboring embeddings, and let me just tell you, like, straight up, this technique is really good at exploratory data analysis. If you have a lot of data, and if you know how to tweak it a bit, you can get a plot like this. And there's this challenge called the Rossmann challenge, where that was in Kaggle a couple of years ago. And there's this research lab called FastAI. They did some interesting work about categorical embeddings. That's why I'm also including it here. And again, this is a technique where you can get a lot of data and then you can compress it into a very small representation and draw it in a graph. You can still do the same with PCA, but here I'm just showing you another way of doing it. And okay, I think I've gone up and down about this, but I'll go back to the first idea I had. And here, like, if you looked at this data, you would notice that here gender and occupation are like grouping together closely over here. And if you have, like, when you look at the data set eventually, I mean, you look at the notebook eventually, you'll notice something interesting about the way this embedding was made. So embedding is just a dictionary of numbers, and usually these numbers or the concatenated vectors, you can be able to arrange them, and then when this t-SNE is able to, when you apply the t-SNE, you can be able to see the data set in another representation, a smaller representation, as opposed to these numbers. And once you have this, you can, what this basically means, there's some similar properties between what occupation someone has, and there's a gender preference as well. And remember, this is not, don't generalize this to everyone. This is just for this data set. And if you continue adding data to that particular array, at least from this notebook, you'll be able to find this, what do you call it? This plot will be able to change. And yeah, like, just to summarize, t-SNE is just a way of helping you visualize data, especially data that comes in these vectors, like a lot of vectors, and then you're able to represent it like this. So when I go back to the point I was talking about, the research lab, so there was a competition called the Rossmann challenge, and that was to figure out like how people's spending or people's habits when they are going to the supermarket. And just with this technique alone, with embeddings and t-SNE or PCA, you can be able to learn a lot about how those people were going to the supermarket and purchasing things just by drawing these kinds of visualizations. And you don't even need to do like maybe a lot of modeling. You have like maybe 8 models trying to figure this out. You can just use this and visualization to figure it out. And back to the theme of this whole presentation about data privacy, how can these techniques help? So if there was a way you can just store these embeddings, as an example, a bunch of vectors of numbers, or within your stores, and you can just show your data set in maybe this kind of orientation as images, that would be another way of at least protecting some information, especially from maybe outliers like this. And yeah, this is just, I'm just showing you some ideas I had for data privacy. at least to do with these unsupervised learning techniques, which is TSNE and principal component analysis. All right. There is this technique that I added called federated learning. And if you use like Google Keyboard, this is just a way of bringing your model to the data as opposed to sending it to a server. So if you use your Google Keyboard, you'll notice it's very good, right? Like there's a reason why it's really good. It's because there's a specific model. That's why the file size for the Google Keyboard is really big, because within those files that are within the application is a certain model. So by model, I mean a certain formula to kind of figure out what is the next thing you're going to type next. So with Google Keyboard, what happens is, like, you see how it's able to help you like write really good messages based on your whatever dictionary you've put there. So they use a lot of this federated learning. And yeah, I think we'll dive more into it when you're looking at the notebooks. And let me see time, I'm not doing so bad. Yeah, so with federated learning, instead of maybe the normal like situation where data is sent to a server, you make a model, and then when this model is made, you throw it back to the, you send it back to the user. The way Google does it is like the model is kind of trained, like either on device, and then all the information stays within your phone, yeah, as opposed to that back and forth. But the normal way that I know like a lot of guys do it is like they just send, in every update, they just send models and you can get it. Another way could be you can have maybe encrypted data in encrypted form, like a subset, and then as you go about your business, like texting people and stuff, like what happens in the background is like a model is trained within your device, and then it's deposited there. And sometimes maybe Google and Apple, Google or Apple will send it back to their servers as just the model, not the data, to just verify that things are working well. So yeah, federated learning, training machine learning models without actually sending data to the server, as an example. So let's have a summary of what I've just like gone through. So data privacy, you can think about it as like a way of like maybe gatekeeping data, giving people particular access to particular things depending on their job function. And then anonymization is just removing those PIIs, and PIIs can be sensitive, they can be indirect, and you can also have this quasi-identifying information, which is dangerous, and also quite personal. But that only happens when you put the data together to figure that out. And here you'll have to do some trial and error to actually figure this thing out, because I think it will change from country to country depending on how information is gotten. And yeah, if you're also one of those guys who gives out their your name and ID like willy-nilly to every single place you go, also ask the question, what do they do with that particular data? Or you can be like me, you come up with a bunch of pseudonyms and ID numbers, yeah, so that you're not like identified, because sometimes you never know what people do this information. So sometimes take your time to ask what they actually do with those names and ID numbers. You can just take my name, you don't need my ID number, so stuff like that, because your ID number is another very sensitive information which you will not want to share willy-nilly. And then the techniques we've gone through is masking and sampling, K-anonymity, differential privacy, PCA embeddings, and federated learning. And then I think this is a link that will take you to something to help you like stay safe in public, in terms of like depending on where you are, there are surveillance systems like that can actually surveil you, and you can be like a lot of information can be known about you when you pass through maybe that camera, or maybe you're in the airport and they do some thermal scanning and stuff like that, or there's something called Wi-Fi scanning as well, where you can easily be identified just because you have a phone. And this will take you to a link that will show you some techniques that you can use to protect yourself in in those particular environments, as well as those other use cases I've talked about. So make sure you check it out. So that's all I had for you guys, at least in terms of covering the core information. So we can now move to the, what do you call them, the notebook, if you don't mind. And at this juncture, does anyone have a question before I move to the notebooks? Again, you can unmute and ask, or you can put it in the chat. So another question from Priscilla. Okay.
I saw somewhere that
Okay, go ahead.
a limitation is that you have to be an expert in order to use these methods and techniques. So are there any ready-made let's say templates or documentation or models that a non-technical person can apply?
Okay, so let me get this straight. So you're saying the techniques I've said here are, yeah, they're like a bit technical, at least. Yeah, yeah, they actually are. And some techniques that you're asking for, other techniques apart from these ones that are non-technical, that can help you with data privacy. That was your question? Okay. So yeah, so there are a couple of things, like if you look at my browser as an example, you'll notice like I have a lot of stuff over here. And the one I can say you can pay a lot of attention to is this particular thing I use here. This is called uBlock Origin. It's like a art block kind of situation, and it's blocked like 284 things, at least in this page. And yeah, that's one non-technical thing you can do. And another thing that you can do, at least for browsers, is there's a particular thing called too long. So there's a certain application called too long didn't read, that whenever you go to a website, there'll be an icon over here that tells you the, what do you call it? That's not it. App for terms of service. So if that application was up, it would tell me, yeah, here it is. It would tell me whenever I go to a site, what things in the terms of service for this particular service that I should be very careful about or very what I should know about. And obviously the ones with B's and A's are the best. And these other ones are not so good. And if you're in the audience and you want to participate in this, you can just come to this TOSDR site, and then you can contribute, and then your information will be aggregated, and then you'll help people at least who install this app to be able to know that Facebook does a lot of weird things, or Amazon when people log in as you're continuously using the session. And yeah, I'd encourage you maybe to download this in your browser and maybe learn in the terms of service about all these companies and stuff. And yeah, Apple is really praised, but even them, they can post content, they can edit content for no reason, and they can delete specific content without notice as well, which can be a bit inconveniencing sometimes. Yeah, so those are like the techniques, at least for a non-technical audience, that you could use. And in addition to the ones that I've mentioned over here. And at that juncture, or at that point, Priscilla, have I answered your questions?
Yes, thank you.
Okay. And also this dataware thing is also non-technical as well. You can check it out. Yeah. Now let me go to the chat. Are there any examples of federated learning apart from the Google keyboard? Yeah, they are. There are quite a number. It's just that that's the one that I've looked into a lot, but Google wanted to release something called federated learning of cohorts. That was a project that would maybe, so there's this part of Google that for the ad business mostly. And so what they were doing is, as opposed to collecting all that information they might have about people who use their services, they were like aggregating it together, and then putting it in this thing called federated learning of cohorts. But I think that, so what happens is, as opposed to singling out each and every information about this particular person and then maybe sending it to advertisers as an example, they were like grouping that information in a way and then sending it to the advertisers, as opposed to the way they were doing it before. Again, I'm just an outside person. I can't really say this one-on-one because I don't work in Google. So that, just look into federated learning of cohorts. And also there are certain libraries that can help you do the federated learning. And let me remember, is it PySift? There's a library called PySift, I think I'm misspelling it. Is this the one? Because I'm actually using code for these guys at a particular juncture. Perform data science on data that remains in someone else's server. I think it's this one, if I'm not wrong. Yeah, I think this is one example that you can use. And then the other link for for too long didn't read. I'm going to get it there. Yeah. So the issue with, so over here, Ronnie has commented, TensorFlow allows has an implementation, but everyone doesn't use TF anymore. PyTorch it is. Yeah, so like if you've watched like a certain video to do with PyTorch, there's a new video for PyTorch, and some people who were instrumental in making PyTorch. PyTorch is a machine learning library that helps you make like really like do deep learning a bit better. So there's one person within that video, it's called Jeremy Howard. He said that the issue with TensorFlow is they like showing you, they have this idea of this is how you do things, and so please follow this. But I think as a researcher, that's not so friendly to researchers. So they like trying out stuff, and yeah, it's a very like closed kind of system when it comes to TensorFlow, at least for doing research. That's why everyone moved to PyTorch, at least in that 2015 to maybe 2019 kind of period, just because of the freedom and because of TensorFlow being very locked out. Although Keras is not so bad, but still it has some of that limitation. But yeah, use what you like, honestly. Okay, so we are here. Oh no. I may need to, yeah, I think I may not be able to run code because I haven't activated the virtual environment. So yeah, I haven't activated this virtual environment, but it's fine. So this is, okay, there are instructions within the notebook of how to actually set this up. And I'd advise like maybe you follow that, and you just maybe make this a bit bigger. Yeah, so here, this is the library for IBM that I use for differential privacy. It's called diffprivlib. And whenever I do this, this means that I am running it like I'm running it in the bash shell, and then here it's like you're running in the bash shell, then you just run it, and then you'll be able to install it. Here are the libraries. So this is an example of, you're not probably using the, what do you call it, the requirements.txt. And yeah, these are some of the imports I do from matplotlib, scikit-learn. And here I'm using like another version of the random forest. Usually you'd expect I'm using like something from scikit-learn, but here I'm using something different. And yeah, these other particulars I'm going to like explain as I go through this notebook. So mostly before you load in the dataset, pandas normally takes a subset of the dataset to figure out what this dataset is about, and to speed that up. And usually you can define the data types ahead of time in a dictionary like this. And this is for if you have some more inside information about the dataset, you can figure out, oh, this is a category, so you just put it as category D type. And here is just, I'm just putting the appropriate data types for each and every column, so that Pandas doesn't do the guessing using a sample. And then once that's loaded, this is for another data set. Don't worry, I'm going to get to that. And then you load this data set to memory. And if you notice, this is actually the presentation that we just had now in like a Jupyter notebook. yeah, this is another thing I wanted to showcase. You can actually do presentation on Jupyter notebooks, and I think when I did this, I did it on the Jupyter notebook. And yeah, let's now go to the techniques. So here's the anonymous data set where we are just finding the concise summary of what the data set is about. And here I was looking at the head, and then this is what you are getting. And then masking, where I add now the column names, you now get something like this. And then for this pandas profiling, oops, where is that cursor? It's usually a challenge for me. Let's get it. I think I'll just have to open the terminal and open it from there. So if I can go to data, cd data, then it's not there, it's in codebook. So let's say open codebook, and then insurance. Yeah, sorry guys, I made a lot of insurance data sets when I was making these presentations, but here we are. This is another way of doing exploratory data analysis. So exploratory data analysis just involves you trying to find out what this data set or cool things about the data set that you can take advantage of before you make your model. Or in exploratory data analysis, you're just trying to figure out, okay, there's a question here. Why diffprivilib overloading? So the reason why I use diffprivilib is it has the whole implementation of differential privacy, where you can add noise to your particular machine learning model. So that's why I'm using diffprivilib, because it already has the implementation of differential privacy, just adding noise while making your statistical model or your machine learning model. All right. So this is a thing I use called pandas profiling, which you may have seen in the imports over here somewhere. Yeah. So where is it? Yeah, pandas profiling, profile report. So that opens up. So how that code looks like is this. So you just call on this method here. You say, I want you to use this insurance data set. This is going to be the title of that particular report. And then you save it to a file in HTML, which I'm just opening over here. And this kind of tells you a summary of what's going on in the data set. And usually what I usually do is I just go here to alerts, and here we get an alert for tax ID. So this is actually the KRA number, by the way. And bear in mind, this data set, I created it with, it's a random data set. If you go digging into the code, like in the repository, this is a data set I made randomly. So that stuff that you find over there is not real. And yeah, this is just that data set I made up. Though, yeah, so if you see values with high cardinality like this, mostly in ML, like this, these are not really usable. So what it means is that these values are very specific, as it says 1001 distinct values. And if you go to tax ID, you see these values, how they look like, and you can toggle the details, and you can see, let's say, a sample. These values are very specific, and if you have values like this, you can't really learn much from them, so you'd rather just throw them out. And again, you get a couple of metrics here, but let's move to another thing so that I can explain other parts like easily. So there's also county. There's a high correlation between the county and marital status. Can anyone tell me why that could be a reason? Why there's a high correlation between county and marital status? Okay, so usually if values are like this, that means they are related in some way, and what happens is when values are related in some way, like you'll have to drop one when you're doing ML because or machine learning, because this other one will overcomplicate the data set, and you might not be able to get a very good model if you have them together. So you may need to drop one. And if you remember, if you remember the rules for doing statistical modeling, at least for linear regression, correlation was also something you're supposed to look into. And it's usually a rule, like if you have like values which are highly correlated like this, you have to deal with them accordingly, or go ask the person who made the data set about it. And since I'm the one who made it, this was totally by chance that these two are related. Maybe when I was creating the data set, I probably made these two in the kind of like the same kind of orientation. That's when they ended up having high correlation. And if you look into this thing, it tells you already high correlation. And if you look into I wonder, where is the heat map? Is it a heat map or correlation plot? Yeah, here it is. So if you look at this particular plot over here, which takes into account categorical and numerical values, and when calculating the correlation coefficient, like you'll find out, indeed, there's a correlation over here. You see, these other ones don't have a high correlation, and most of the times, if you have a lot of correlated values, it will make it hard for you to make a model with this kind of data set. So you might need to remove one. Another one, date of entry has unique values. Yeah, so the whole point of this pandas profiling is you're given this summary of what's in your data set, and usually you need to create like a lot of plots to figure out information like this from the alerts, and here you just get a summary over here, and then you can act on it like pretty fast. So yeah, this can be maybe a dashboard for a particular data set, maybe in like a hospital as an example, to display summary statistics like this. Like here you can see, for instance, here gender, the representation, like it's not so, they're not, the male and female within these groups are not so skewed. They're pretty much the proportion 510 and 491, that's not so far away from each other. And if you look at the category frequency, we have 50% and 49.1%, not so bad. It also does, it looks at the words as well. It looks at the frequency of those particular words of female and male. So if it was named a bit badly, maybe it was a data entry error, it would tell you over here. It looks at statistics about the characters as well. Okay, there's some stuff in the chat. People are saying stuff in the chat. Different marital customs apply to people living in different counties. Yeah, that could be a reason. And castle dimensionality. Okay, and then here I see you have Kendall and Kramer statistical measures. I'm curious what they show of the data. So also for this correlation metrics over here, if you toggle here, you can get an explanation as to what's going on or what exactly this correlation coefficient is over here, and you get an explanation over here. So someone has asked for candle, so here's for candle how it looks like, and for Kramer this is how it looks like, and a small explanation here. Yeah. So yeah, it will take me quite a while explaining correlation, all of this, and I see I know this presentation was supposed to be for till like 8 o'clock, but I'm trying to like maybe go through the particularities like a bit faster. Hopefully I'm not losing you guys. So yeah, so this is just my summary about this thing. Is just a way of representing your data or doing the summary statistics about your particular data set. And this will be probably very useful, fast, what do you call it? Fast MVP for visualizing data as a dashboard, or visualizing data in a dashboard, depending on who you're presenting it to. And yeah, this thing is pretty high level, having a lot of statistics that you can look into, summary statistics like median, mean, max, median, things like that, and things like characters and Unicode. Then you can toggle here if you want an explanation, and you see it takes you to that particular page. So yeah, this is pandas profiling. Technique I use to do my exploratory data analysis pretty quick, and I'd encourage you to look into it some more. It even has some interaction terms over here that you can look into, and correlations, and also a sample of the data set as well. Yeah, so pandas profiling, make sure you look into it. All right, that's the summary. And then we have the columns over here for county, gender, marital status, and all of this. And now let's go to the techniques that I talked about. Now here, this is just a way of finding a sample of data. And then remember I talked about, this tells you the proportion of each particular group here. And usually the group I wanted to protect here was the registered partnership, in case maybe there's a law like, oh, we don't have registered partnerships in this country, man. Maybe you don't want to present that to maybe a huge group of people, let's say, in a newspaper. You might use this technique to to blur those that information. And as you can see here, when I do this value counts, you just get so this is the whole data set. This is what you get. So I want you to pay attention to these proportions and what I get from the sample. So if I use a sample of 100, you see we are getting something close to what we have here. And even when you're reporting, clearly separated as take the biggest proportion. And then obviously marriage kind of shoots up a bit. So that's something we need to put into consideration. That's why we go a second step to now do this technique where I take a random sample. And yeah, I wish I could run this. I think I didn't set up a partial environment well. So I just take some time to kind of look into this, and then yeah, play around with it, and then figure out how you can change it again, and you get different proportions. So once you run this, where we are taking like a random sample of the data set, and then we are using these particular values over here as the proportions. And then if you calculate the sample, you'll realize you're getting something very similar to this, right? You see, so instead of presenting this, you could present this. Yeah, so that's just sampling. And you can appreciate the values here being similar to the other one. Then here we have K-anonymity, where I do I look at the number of instances of age entire, and then I look at the count of age entire. Then I remove the index, and then I put this value as count. And instead of saying index, it's going to be count. Yeah, so the people who are 30, they're using the bronze tire, they are 7. And then there's another group of 30-year-olds who are like using the silver, and they are 4. So here, a very important function that I want to highlight, this PD cut. You can use it a lot for when you're trying to get categories out of values that are integers like this. And here bins are equal to 4, so it will put it in all that data into like 4 bins. So these are going to be, or this age range from the guy who's like the oldest to the youngest, they're going to be put within groups of 4, and that is what's done over here. And then when you calculate the value counts, these are the proportions you get, right? And then you ask the question, how many groups of 4 can you get from this data set? And if you do that in this using this particular code over here, you get none. So basically you have blurred pretty much these groups over here because these proportions are pretty much the same. And then for differential privacy, this is now the code. And as you can see here, values between 1 to 9, I almost confused myself over there. And then when I calculate the mean of that particular value, it's for that particular array, I get it 4.8 in the original. And then when I use the differential privacy tools to calculate the mean, so I'm not using the mean function from something like here I'm using like NumPy. So instead of using the NumPy one, I'm using the one that adds noise. And there's a budget accountant looking at for the number of times I do this calculation, how much is my spend of my this epsilon value. And again, if you run this a couple of times, this thing will come up with an error, and you will be able to see what exactly is going on there. So if I remove this, let's see if I can run this. Haha, syntax error. Where is the syntax error? Multiply each. Oh, they're supposed to put a comment there. So if I run that again, x is not defined. Yeah. If I run this, like, things will just blow up. So let's just leave it at that. But I encourage you to run this in your virtual environment. And over here, you'll notice that over here, I'm adding like a bit of random numbers over here. And then what I'm doing is I'm multiplying it by, I'm multiplying the whole array with random numbers. And then I'm removing some values. And then here is this is just a long way of implementing the differential privacy thing that I've demonstrated to you. And this is a way of doing it step by step. So again, I encourage you to look into that. And then here is another one. And this is just to demonstrate. If you calculate this value over and over again, your budget will run out and you will not be able to run this particular function. So that's the whole essence of differential privacy. Like if people have access to a particular data set and they're able to do a particular calculations, they can only do calculations up to a certain point, depending on their what do you call it, the epsilon value. And then here is just more feature engineering, and like the guys who are interested in how I came up with all this, then it's pouring where I am. I hope you guys can still hear me. Yeah, if you're interested in finding out how I made all this, you can just come to the utils folder over here, and then you can find out how exactly I made this data set. So there's this whole vectorizer that I use for coming up with categorical values. And so there's one-hot encoding and label encoding. So one-hot encoding and label encoding, I do that in one step. And this vectorizer helps me do that. And if you've been in one of my meetups, I might have talked about that. So yeah, I encourage you probably to look into this feature engineering.ipython notebook in the utils to learn how I got all this. Because this is very important when you're doing statistical modeling. And here I am just preparing the dependent and independent variables to use for ML. And then this is another thing that I see in a lot of notebooks where people only make the train and test splits. I usually break it down into maybe even more groups. So this is a very small section of the data that I use. This is like the train, test, and validation in one particular function. So this function will probably come in handy, especially when you're doing this thing called model validation, where you're trying to figure out whether this model is actually performing well. And then here's the random forest classifier. This means I'm using all my cores. And remember the epsilon parameter here. Again, this now helps adding in noise in your work. And remember, if this value is low, there'll be a lot of noise. So even the values here, they'll be very hard to get very accurate values. But again, if you move this value to something a bit higher, you're getting the original data set. So yeah, that's something to take into consideration. And then this one allows me to get the same results over and over again when I run it. This one now tells me what's going on as the model is being fit. Then what I'd add here is something called class weight. So Abdi taught you guys about feature engineering, and also this has a bearing to that, especially for classification problems. So here I just put balanced, and that helps with normalizing the classes, and it will help you with getting a better values on this particular metrics. And yeah, so the one I usually take into consideration a lot Yeah, so the one I take into consideration a lot is F1 score, because it's like a weighted between precision and recall, so a mix of specificity and sensitivity of the model. And this one is doing pretty badly because it's mostly doing guesswork, because the accuracy is like 53%. That's really bad. So yeah, that's because of this epsilon parameter here. And probably I need to do some more feature engineering where I need to remove those columns of interest. Then here's some pros about random forest. And here I now do the Now we move to PCA, principal component analysis, and this is the function I use from scikit-learn. And once you apply it, you get a data set of, you notice that the memory usage becomes a bit smaller because, like I said, it's a dimensionality reduction technique and data compression technique. So you get to use less data than usual and still maintain the particular characteristics of the data set. So we move from 82 columns to 2 columns, and the data set will still follow the same pattern, and that is if you draw it in something like this. So here we have embeddings, and here was the code to actually apply the embeddings. And this is in summary just turning the text into like an array of 3 numbers, as you can see over here. And really hope you guys can still hear me. It's really pouring here. And once you have that put together, this is just a way of organizing the information a bit better. And then for visualization, and then these parameters over here, you get issues with a lot with this complexity, because so when it comes to t-SNE, it's a way of arranging your data like in a particular way. And what I mean by that is your data has this particular intricacies, and what t-SNE helps you do is, like, if you have this data and you want to present it to people in a very compressed format in a visualization, and you have all these dimension, all these columns that you need to put into consideration, t-SNE will now shrink that down. So you can say t-SNE is also a way of compressing that information and still retaining the information that you need. So as for these particular parameters, like, I think it will take me quite a while to explain this, so I'll let you guys look into that just for the sake of time. And it's really raining over here. So yeah, this is the code to help you make up this particular, what do you call it, data set. But this might change since I didn't, yeah, this might change on when you run it on your computer. So there are particular things I didn't put into consideration, maybe because the data set is very small. That's why that happens. But yeah, just experiment, add more data, and then you're probably going to see.
Yeah, I'm getting inaudible. Can you hear me now? Maybe a thumbs up from a couple of people. Okay, you can hear me. Great. Okay, you can hear me. Man, this is why I decided to take this route, so that we are able to finish early and we can have more time for questions. So that's t-SNE and embeddings. And then what you have over here is I'm downloading data from a repository over here. And here, this is just basically bash. I'm using wget, and if it times out after 300 seconds, it's going to retry 3 times. And
What do we have here? Yeah, it's a bit difficult to see because that bar over there is kind of obstructing everything. Yeah, so this is kind of like a safe way of downloading data from a remote source, which is GitHub, and storing it in particular files called spam and ham. And here we're just gonna look at federated learning and how you can implement it for sorry, like, this is a way of implementing the
what do you call it, the federated learning. And here we are just doing it for spam classification, like that folder that you have in your email, that maybe this is an irrelevant email or just maybe ads. And we are going to teach like a computer how to detect spam or harm emails. And I borrowed this example from the book Grokking Deep Learning, and you can find that in the references in the repo when you look at the README. And here, these are just utility functions that if you're trying to implement a neural network, and in particular that uses also embeddings, and I'd say maybe take the implementation over here more seriously than what I just showed you. So in the first, and this is a lot of code, and I don't think I can go through it in this session. So this is the piece of code that's probably very useful, because these embeddings are also using the large language models a lot, things like ChatGPT that you may have used. So this just helps create a representation of the text in what do you call it, in kind of like a numerical format. And you can now do, and you know, for ML you need to have data in a numerical format so that you can be able to do any interesting calculation on it. This is a lot of code. And yeah, so I just encourage you to read this book by Andrew Trask from Manning Publications. And here what we were doing is just preparing the data. So you're moving from having data that's text format to a bunch of numbers in a vector. And then here we are doing the train test separation. So this is a long way of doing it. And then once you have those, you're gonna have to append that data into these lists. So this is just putting the data into this list that we've instantiated over here. And then we create a training loop and use stochastic gradient descent. And this is a regression problem. That's why we're using mean squared error. And then once you calculate, we'll now get values. So this is the vanilla way of how you would make a model to figure out what text is spam and what text is harm. And if you had your own text, you put it over here, it will tell you whether it's spam or harm. And then here is an implementation of federated learning. Here you're just taking a bit of the data, but again, this data is not really in the best state, because I can still be able to read and decode this data. But a better way would be adding this thing called homophobic encryption. So what that means is we encrypt the data. So we work on the data in an encrypted form. And when I say an encrypted form, it's not like when you read the data in, like, let's say a file, it won't look like the way you're reading it right now. Yeah, it will be a bunch of jumbled characters. And this fair library was supposed to help you encrypt maybe the number 5 and 3, and then you do the calculation, and then you're able to decrypt it and say it's 8. So this might be familiar if you work on this data type called Parquet, and because the numbers look kind of like that as well. So now how do you apply this kind of method for this particular application? So you do the same thing, but for here, what you do is you take something called the weights. So weights are just part of the equation. So you can think a bit about it as the coefficient. So when you're making a machine learning model, you're making this formula, this very long formula, depending on how many columns you have, that has probably a summary of what the data set is about. And if you substitute values into that formula,
you're able to find like, oh, this email is spam or harm. So within the particular, what do you call it, implementation of ML that you're doing here for spam and harm, there's a very long formula that will now tell you whether this is spam and harm. And if you just give it the particular values, that means the representation of your data in a bunch of numbers, like it will be able to spit out a prediction like, oh, this is spam and this is harm. And here, that's what we are kind of doing. And here, if you're keen, you'll notice we are just adding a public and private key. So for each and every data set, we add this public key. And then when we are doing the on-device training, and over here, I think the implementation for these guys was data is trained in an encrypted form. That's why they're encrypting it over here. And then when you want to access that model, you have within your device, you have a key. So when the model is sent to your device, as an example, what happens is like you'll need to decrypt it using this key. And then once you have that key, you'll be able to give them, or everyone will have their own version of this spam and harm classifier. And if you look at this, the model is training and you get accuracy, like the percentage of correct in the test set is 99.15. That means this is probably a state-of-the-art model for classifying harm and and spam. Yeah, so that's what's going on over here. So in summary, what is going on is these guys are using a copy of an encrypted data set, and you need to have, and everyone has their own key. So when the model is training, maybe on device, it's now training on data that's encrypted. And once you have that particular model, you can be able to decrypt it, and it will be able to classify whether it's spam and harm. So yeah, I'll just let you guys go through that data set and find out what's going on. So this other data set was that was made was about actual measurements, like critical measurements of particular, what do you call them, patients within a hospital. So this is a heart rate, blood oxygen, and temperature, and then just interviewing the particular person and asking them whether they feel, how they are feeling. And obviously, again, for the status, I kind of removed the particularities and just put it as well, tired, allergy, or off. And this is another way of applying some of the techniques we learned. And again, if you present this, like, you'll not be able to single out who are feeling off. And that was it. That's what I wanted to share with you guys about differential privacy and keeping about data privacy. And yeah, I hope like some of the things I've mentioned, like you'll be able to use it in your work and maybe protect client data so that you are compliant with the data protection laws that we have here in Kenya. So yeah, that's all I had for you guys. I think I will move the mic to maybe MK or Sylvia for some final remarks.
All right, fantastic. Thank you, Mainye. Yeah, I don't know where the round of applause is, but I think we can do round of applause because the session has been packed with content. There's a lot that you have shared, and yeah, this is, yeah, just saying great job.
Sorry, Sylvia, there's someone who's raised their hand. I think it was Ronald or something. Did you
Oh,
want to
yeah,
ask a
sure.
question?
Sure, please do.
Okay, maybe that was a mistake. Sorry. Sorry, Sylvia, please continue.
All right, no problem, no worries at all. Thank you. Thank you very much for taking us through the session, Mainya. Thank you for guiding us very carefully and even through the nitty-gritties, adequate examples, using all the necessary tools. And a big round of applause to the audience as well for really engaging and asking the right questions and dissecting this topic thoroughly. Again, if you missed it, I don't know if Mainya, you can share the slide with the QR code for the slides presented in case anyone missed it, just so that, yeah, they can be able to catch up, or even just pin it for later, share it with people who are not able to make it for this particular meetup. Yes, that is, all the materials will be found there. Share it with anyone who is not able to make it for this particular meetup. Yeah, and that as well. But nonetheless, the recording on this will be uploaded later to this event link. So this same event link will have the same upload later. So when you look through the event later on, you'll be able to see the event wrap up. It will have this particular recording. So in case you missed it, you'll be able to find it there. That being said, I don't know if there's anyone with anything else, but allow me to share some links in the chat, especially with regards to our Africa's Talking communities. So I will share three main links. One, to join this AI and ML community. So if you liked this AI ML presentation, it's your first time here, or you always miss out somehow on this particular meetup, then worry not. I have shared in the chat. Spacing on this is very odd. Yeah, I have shared, let me reshare that, making it a bit more visible, because I see there are some links that are not as visible. There we go. So I've shared four main links. First one on the AI and ML community, so that next time you do not miss out on this, because we have this every month. Every month there's one meetup in the AI ML community. So that link will redirect you to the AI ML community page. Please join as a member. If you're not sure whether you have joined, just click on it. If it tells you join, you have not joined. If it tells you leave, then you have joined. So don't leave. So click on that link, and then with that, you'll be able to get any updates whenever a new event is published. You'll be able to get it on your email, and then you can always RSVP from there, just to ensure you don't miss out on that. Second link is the Women in Tech community. At Africa's Talking, we have a Women in Tech community where we have at least one event per month. So at least one hackathon per month, every last Wednesday of the month. That is in Nairobi. And in Kampala, we have a meetup. Every last Thursday of the month, there is a meetup in Kampala for the Women in Tech community, and it will be scaling to other countries as we continue. So if you want to get updates on that and not miss out on any of those events, the link has been shared over there to join the community. Same thing, you will be redirected to the community page, join, so that you can receive all of these updates on all the events we have. And finally, for the Africa's Talking Open community, we have at least a hackathon every month. So every last Thursday of the month. In case that isn't very clear, what I simply mean is, for this particular month, this is July, we have the Women in Tech Hackathon on 31st July, which will be the last Wednesday of the month. We have the Open Hackathon on 25th July, which will be the last Thursday of the month. So those are the two hackathons we'll be having in the Nairobi office this month, that is July. So you can join that community so that you also get updates on that and do not miss out on such sessions. If you've never been to a hackathon, don't worry about it. Don't panic. Just RSVP for the next one, which you can find on our upcoming events page. You'll be able to see a list of upcoming events, a calendar with all the upcoming events. RSVP and join us. Do not worry about not knowing what to do. We got you like that. We'll be able to guide you through and take you through what you need to do in order to be in a hackathon, how to build the solutions, because it's very hands-on. We'll be using Africa's talking products, and we'll be able to tackle any of that. Before I finish, I see there's a hand from Ronnie. Feel free. Yes, Ronnie, your hand is up.
I hope you can hear me. Hello. Can you hear me?
Hi. Yes, loud and clear.
Okay. So I have a question for Ben. So at the final end, at the tail end of the presentation, we talked about Parquet. Do we call it Parquet or Parquet? Parquet. Parquet. So when I interact with the Parquet file, usually find that the columns usually don't have the discrete names of the column. Let's say like the name, first name, last name, ID number, gender, like usually numbers. Could we categorize that as, let's say, masking? Because most of the Parquet files usually come like that, like the columns. Mostly, okay, for the ones that I've interacted with, they usually just have like numbers in the columns.
Yeah, yeah. Using Parquet is actually a masking technique, and I showed that in the previous meetup where we talked about data version control, and that's just a way of having an easily shareable workflow, uh, a shareable workflow that you can collaborate with teams. Maybe you're working in a team, and you can be able to keep track of particular metrics of interest like accuracy and all that good stuff in and out. Yeah, Parquet is a way of masking, and in fact, it's actually a way of masking and encrypting. So that's actually a good technique you can use. So uh, if you wanted to maybe do some uh, to hide like particular information, like obviously not in a particular way. Maybe it's an S3 bucket. You can do the two techniques. You can remove the column header, and then you put the data in Parquet, and then you'll have maybe achieved a very high level of encryption, because it's, again, if you don't have context about these particular data sets that are in this Parquet format, like you will not be able to kind of ascertain what the data set is about. So yeah, that's actually a good technique, and uh, I, yeah, just try it out. And another reason why I like Parquet is that, remember that section where I was defining the data types? Like, if you swap that out to reading Parquet, you don't need to define the data types, because that information is already embedded within the file. So if you're very keen in the Parquet file, you'll see the column names of every particular, of each column has been embedded within the Parquet file. So Parquet files are also good for that, embedding the data type for each and every column. So okay. Any other question before we wrap things up? There are no other questions. So yeah, thank you, Sylvia, MK, uh, for the help and support putting this together, and for the helping out in the previous meetups. And yeah, and I'm so excited. Like, we have had a lot of guys. I think we had like at some point 29, 30 people who are logged in. So I don't know if you guys like virtual presentations more than in person. So if you like virtual more, maybe you can give a thumbs up in the chat, and then you can kind of know maybe if you like those more. Oh, wow, there's one. There is two. Okay, for WhatsApp group, I don't know about that. Maybe MK and Sylvia, you can you can
Yeah.
advise.
Yeah. Let me take that for the WhatsApp group. At the moment, we don't have a particular WhatsApp group for the AI ML community. Rather, we just have the WhatsApp community for the entire Africa's Talking community. Yeah, that's what we are using at the moment. No plans to create one, particularly for the AI ML team, are underway. Yeah.
Okay. Okay. Yeah, that's all I had for you guys. Thanks for all showing up. The next meetup will be probably about Docker, or if Ronnie is ready for his presentation, like you can have Ronnie's presentation first. Yeah. So yeah, we'll talk about that internally, and but it will be a bit either it's gonna be either Docker, talking about Docker and how you can leverage that for data science, or we're gonna talk about time series prediction, which is predicting things that are or certain events. Uh, yeah. So yeah, that's all I had. See you there.
Awesome. Thank you, Ben. Thanks for the feedback on the virtual platform being better. I see the country teams Rwanda are interested in virtual. You're very welcome. So when we have the virtual event, you're always welcome to join in from wherever you're at. So we'll be having more of these. Just be on the lookout. We'll be sharing links for virtual events just so that we can include more people from all across in some of these sessions. Alongside that, tomorrow there will be an email that will go out just on the post-event survey or feedback on how the event was. Please fill that in. Let us know what you would prefer. If you prefer the online sessions more, write it on that post-event survey. It's a very short one, probably 1 to 2 minutes. So just fill that in. And then once we have that feedback, we'll be able to really implement more of this. Other than that, thank you very much. It is pretty rainy here in Nairobi. I hope wherever you are at, it is better, or if it's the same, all the very best. Sending warmth your way, sending the sun your way, I don't know. But I wish you all a very good night and see you in the next one. Goodbye.
Bye. Sure.